Finding equations for lines. Given enough information, you can find the equation for a line. So one of our most commonly used general equations for lines is the point-slope form of a line, which is given right here. And this is an equation for a line that has the slope in it and then one specific point, so x1 comma y1. So you can use this formula if you know a point on a line and its slope. But you can also use this formula if you know 2 points on the line, because whenever you know 2 points on a line, you can find its slope. So in general, you use this if you know a point on a line and its slope, or if you know 2 points. Because then you can find its slope. Okay, so let's look at an example of how you use this general line equation to find the equation for a specific line. So we're going to find the equation of the line through the points -3, -5, and 1, 7. So you don't have to make a graph of this situation if you don't want to, but just to make it clear what we're doing here, we're going to look at a little picture. So our goal here is to find the equation for the line that connects -3, -5, so somewhere like right there, and 1, 7, which is way up here. So we want to know what's the equation for a line connecting those 2 points. Now, to do this, we can use slope equation for lines. So that is y minus y1 equals m times x minus x1. Now, to use this general equation, we need to know 2 things. We need to know the slope of the line, and then we need to know a specific point on the line, an x1 comma y1. Now notice that we actually have 2 points on the line. We have 1, 7 and -3, -5. And so we can use either one of those to be our specific point on the line. In other words, we need to use this equation, a point on the line, and we actually have a point. We have 2 points. So what I'm going to do is I'm going to use x1 comma y1. I'm going to use 1, 7, but I could use the other one. And then we also need to know the slope. So we need to know m. Okay, so what is the slope of this line? Well, we can find the slope using our 2 points. So remember, m is y2 minus y1 over x2 minus x1. Okay. And so what I can do is I can use our 2 points up here, and I can plug these numbers in to our general slope formula. So let's call this one right here x1 comma y1, and then let's call this one over here x2 comma y2. This means that we have x1 comma y1 is equal to 1, 7, and x2 comma y2 is equal to -3, -5. And if we go ahead and plug those values into our general slope equation, we're going to get m is equal to -5 minus 7 over -3 minus 1. If we simplify that, we get -12 over -4, which is exactly equal to 3. So the slope of our line is equal to 3. Now if we go back up to the picture up here, that kind of makes sense. We get a positive number, and it's pretty steep, so it's positive, so 3 goes with that, and it looks pretty steep, so that also kind of corresponds to what we see here. Okay, now what do? We're going to use this equation here, and we're going to plug in our point. So we're going to plug in our point, and we're going to plug in our slope. Okay, so how do we do that? We have y minus y1 equals m times x minus x1. We know that m is equal to 3, so I can put that in the m spot. And then we know that x1 comma y1 is equal to 1 comma 7. So I'm going to put 1 in the x1 spot and 7 in the y1 spot. Now at this point we have an equation for the line that connects the 2 points. So this thing right here is a sufficient answer. It's an equation for the line. What you're often going to see is people will multiply it out and write it as y equals something. So it's very common to do this. Distribute the 3 to get 3x minus 3, and then add 7 to both sides. So I'm going to add 7 here and add 7 here, and essentially solve for y. So you get y equals 3x plus 4. And this is going to be our answer. Okay, so the steps are, to summarize, identify a specific point on the line, find the slope, and then stick the point into x1, y1 and the slope in for m, and then solve for y. Now, this equation that you see here, when we solve for y, it's actually called the slope-intercept form of a line. So if you see a line in this form, so y equals mx plus b, this is called the slope-intercept form for an equation of a line. The slope-intercept form is pretty cool. It actually has the slope right here in this spot. So notice that like our slope of the line was 3. We know the slope was 3. So when you have your line in slope-intercept form, you can actually read off the slope from the equation. So the slope is always going to be in the spot right here in front of the x. And then b, or the number right here, this is called the y-intercept. And it's actually the place that the line crosses the y-axis. So 4 right here, that's actually where the line crosses the y-axis if we look up at the graph. So let's take a look at the graph again. Okay, so if we're looking at our picture, this point right here is actually at 4, or y is equal to 4. Now, I graphed it pretty quickly, so it looks like it's at 3, but if we were to do it more accurately, it's actually like at 4. So the two most common equations for lines that we're going to use are the point slope form, which looks like this, and the slope intercept form, which looks like this.